So in aqueous solution, metal oxides can react with acids to form a salt in water. In this case, they're giving me a reaction between iron 3 oxide and hydrochloric acid, okay? Take a look. This time, in the product, I'm gonna get iron 3 chloride in water. In the first question says, how many grams of iron 3 chloride will be formed when 35 grams of iron 3 oxide react with 35 grams of hydrochloric acid? So first part is about determining what is going to be the amount of that theoretical yield. Then it says, from part A, how many grams of excess reactant remain? Here in this class, we're gonna learn how to get the leftover, okay? And here, they're giving me the percent yield and they're asking me about the actual yield in grams. So this is an exercise, very nice, and we're gonna be working with that. Okay, so let's begin with the exercise. It is a reaction that is already balanced. Nice, okay? So we're going to start very nice from there because it's already balanced. So the information given in the problem is that I have 35 grams of each reactant. That's what the problem is giving me. It's giving me the exact same amount for each reactant, okay? So the first thing that we need to do is, well, in my case, I'm going to rewrite the expression, okay, so I can show this the procedure right before the equation. And then I will focus on getting the molar masses. Take a look. So this is what the problem is giving me, okay? It's giving me this reaction and the provided information for each reactant is 35 grams. Okay, that's exactly what I have in each. I have 35 grams and they're asking me the first part, part A, it says, how many grams of iron 3 chloride will be formed? So I'm gonna look for the amount of grams of iron 3 chloride. To know that, what I need to do is I need to work with my reactants. That is my first step, okay? But before I go into that step, I need to analyze, or more than analyze, I need to calculate the molar masses, okay? Of all the substances that are involved. In this case, I'm working with iron 3 oxide, hydrochloric acid, and iron 3 chloride. Those are the three substances where I'm gonna get the masses, the molar masses. So the procedure of the molar masses, I'm gonna do it here, okay? So I have 2 iron plus 3 oxygens. 2 times 55.85 plus 3 times 16. I'm already using the values rounded, okay? How much is this?
159.7.
0.7
Yes.
grams of iron 3 oxide over 1 mole. The same substance. So I have my first molar mass. Then my second molar mass is HCl. In HCl, I have 1 hydrogen plus 1 chlorine. Remember, just the molar masses. Here, you don't see coefficients, okay? Here you ignore the coefficient, you're getting molar masses. So this is going to be 1 times 1 plus 1 times 35.45. How much is this? Guys, remember that all the molar masses are written over 1 mole. Do not forget. I'm sorry I'm being this messy. Is that this procedure requires a lot of work. So I need to finish. The other molar mass that you have to get is iron 3 chloride. Okay, so the molar mass is 1 iron and 3 chlorine. So this is equal to 1 times 55.85. How much is this?
162.2.
160.
62.
162.2.
Yes.
Okay. So these are grams of iron 3 chloride over 1 mole of the same substance. So you have all the molar masses that you need in the problem. Now, what do? We're going to work only with the reactants, okay? Because we need to identify what's going to be the theoretical yield. So we're going to work with the reactants. Iron 3 oxide and hydrochloric acid, okay? So let's see. For the first reactant, that is iron 3 oxide. They are giving me 35 grams. So I need to do that procedure grams to grams, okay? The question says, how many grams will be formed when 35 grams react, okay? So my procedure is from grams to grams. Now, remember you can place the invisible one, you can make it visible, okay? And now let's work. In the procedure gram to gram, what is the first step? Molar mass or molar ratio?
Molar mass.
Molar mass, okay? So the molar mass of iron 3 oxide is 159 grams, 0.7 grams of iron 3 oxide. Remember, you must get rid of the units, grams with grams, and iron 3 oxide with iron 3 oxide. It's not just about getting rid of the units. Don't be lazy. Write all the units. Okay, what is the next step? Okay, above, we're going to write how many moles?
1.
Always, molar mass, always 1 mole, okay? So in here, it's gonna be 1 mole of the same substance. Don't be lazy. Okay, what is the next step? In
Molar
grams to
ratio.
grams, molar ratio. My molar ratio between what? My molar ratio between iron oxide, iron 3 oxide, and iron 3 chloride. That's the relationship I'm doing, okay? So how many moles of iron oxide?
1.
1 mole iron 3 oxide. And how many moles of iron 3 chloride?
2.
2 moles of iron 3 chloride. I get rid of moles with moles and iron 3 oxide with iron 3 oxide. And we continue. What is the last step?
Molar mass
Of which? Of the substance that I'm dealing with, that is iron 3 chloride, okay? So where am I going to write the moles?
down.
Down, okay? So I say in 1 mole of iron 3 chloride are 162.2 grams of iron 3 chloride. I get rid of the units. Moles with moles, iron 3 chloride with iron 3 chloride. How much do you get?
Seventy-one point one.
71.1.
71.1
The units?
grams of iron trichloride.
Okay. We did the first reactant, but we need to compare with the second reactant. Okay. So the next step is we're going to do the same procedure, gram to gram, but this time with the second reactant, that is hydrochloric acid. So the information for hydrochloric acid, they are giving us 35 grams. So we start with the given, 35 grams of hydrochloric acid. Okay. What do I use in the first step? Molar mass, molar ratio.
Molar mass
Where do I write the grams?
down.
Grams, HCl, down. How many grams? 36.45, the molar mass. In the upper part, you're going to write 1 mole. Always molar masses are over 1 mole. So this is 1 mole. 1 mole of hydrochloric acid. Get rid of the units, grams HCl with grams HCl. And we continue to the next step. In the next step, what do we have?
Molar ratios.
Molar ratios. Now, these molar ratios are going to be between the second reactant, HCl, and the unknown, iron 3 chloride. So, how do I write this molar ratio?
2/6.
2/6. Very good. Okay, 6 moles of HCl and 2 moles of iron 3 chloride. In the last step,
Molar mass.
molar mass of the unknown substance. So my moles are going to be written in the bottom and above 162.2 grams of iron 3 chloride. Get rid of the units. Moles HCl with moles HCl, moles iron 3 chloride with moles of iron 3 chloride, and the remaining are gonna be grams. How many grams?
61.92.
61.92.
51.
51. 50, yeah. 51.
51.92.
Okay. So, question now is, what substance is the limiting reactant?
HCl.
HCl. The limiting reactant, remember, is the substance. So the substance that produces less is the limiting reactant. In this case, HCl is going to be the limiting reactant. Wait. So HCl is the limiting reactant. Now, what is the theoretical yield?
The limiting reactant.
Not the limiting reactant, the amount produced by the limiting reactant, okay? So these 51.92 grams are going to be my theoretical yield. The theoretical yield is the amount, okay? And the limiting reactant is the reactant. So this one, theoretical yield. Okay, now in the part 2, okay, we already did one part, okay? We did stoichiometry and we found the limiting reactant and the theoretical yield. If you know the limiting reactant, you also know the excess reactant. What is the excess reactant?
Iron trioxide.
Iron trioxide, okay? So this is the excess reactant. And this one is important, okay? Because for the question number 2, it's about calculating the leftover. It says from part A, how many grams of the excess reactant remain? So after the reaction takes place, all my limiting, all the amount of limiting reactant is gonna be gone, okay? All the amount, all the 35 grams are gonna be gone. But I want to know from the 35 grams of the excess reactant, iron trioxide, how many grams will remain? So I'm going to calculate the leftover. So how do I do that? Now, to calculate the leftover, pay attention here because this is, you haven't seen this, but it's still part of stoichiometry. So to calculate the leftover, you're going to relate the limiting reactant with the excess reactant, okay? It's a relationship that you're going to establish here in the reaction. So you will relate HCl with the excess reactant, iron trioxide. So what's going to happen? Okay, this is part A. Let's work with part B. In part B, you're going to relate limiting reactant with excess reactant. This is going to give me the amount used in the reaction or the amount consumed in the reaction, okay? So we're going to start with the limiting reactant. In the limiting reactant, I have 35 grams of HCl, okay? So I'm going to relate grams of HCl with grams of iron trioxide, okay? So this is grams HCl, 2 grams of iron trioxide. That's the relationship I'm gonna be doing. So again, it's a procedure gram to gram. Okay, it is a procedure gram to gram. So we start with a given. What comes after the given?
Molar mass.
Molar mass. What is the molar mass of HCl?
36.45.
Okay, 36.45. Those 36, I'm going to write them in the bottom, okay, so I can get rid of grams. So wait, 36.45 grams HCl has 1 mole of HCl. Get rid of the units. What comes after?
Molar
Ratio.
Molar ratios. This molar ratio is only between the reactants, okay? My molar ratio is invisible 1, okay? Invisible 1 and 6. Where am I going to write the 6?
down.
Up or down?
Down. Because our moles of HCl, you can cancel up.
Okay. Exactly. There are moles of HCl, so it has to be down. Now, 6 moles HCl and above, invisible 1 mole of iron 2 oxide. Do I have the mass of iron 2 oxide? Yes, right?
Yes.
159.7. Okay. Now the last part is I use the molar mass. Where do I write the moles?
Down.
1 mole iron 2 oxide, 3 oxide, sorry, has 159.7 grams of the same substance. I get rid of the units. How much I got?
25.66.
25.66 grams, 56 grams of iron
of iron trioxide.
3 oxide. Okay, what is this? As I told you earlier, this is all the grams that were used up in the reaction. This is the used amount. So how do I get the leftover? Very simple. Take a look. To calculate the leftover, it's going to be the given excess reactant minus the amount used, okay? So they gave us 35 grams of iron 2 oxide. And we used in the reaction only 25.56 grams. Don't be lazy, write the units, write the substance. How much is this?
9.44.
9.44.
9.44 grams. So, question 2, from part A, how many grams of excess reactant remain? You can call it remain or leftover. You can answer like in a sentence. There are left 9.44 grams of iron 3 oxide. After the reaction takes place, there are left 9.44 grams of iron 3 oxide. That's, guys, how you get the leftover, but that's not it. What comes next? the last question. It says, if the percent yield of iron 3 chloride is 92.5%, what is the actual yield in grams? Okay, now in the part C, they're asking me about the percent yield, okay? They are giving me the percent yield and they're asking me for the actual yield. Remember that the actual yield is what you get, what you really get in the lab, okay? Most of the time, I'm gonna give it to you, but if I ask you to get the actual yield, I should give you the percent yield instead, so you can do the isolation, okay? So in the part C, we're gonna be using the formula for percent yield. Percent yield is equal to actual divided by theoretical times 100. Okay? So in this exercise, they are giving me the percent yield, and you know the theoretical yield, and you need to look for the actual yield. Okay? So we need to isolate. So the isolation is gonna be percent yield multiplying the theoretical yield and dividing by 100. This is equal to the actual yield. Okay, the theoretical was dividing. So when you move it to the other side, it's going to be multiplying. 100 was multiplying. So when you move it to the other side of the equation, it's going to be divided. So that's why here the 100 is dividing. Now the percent yield is, given in the problem, it is 92.5%. So we say 92.5%. Okay, theoretically, the theoretical yield is 51.92 grams. So you're gonna make that substitution here. Grams of what? Iron 3 chloride. All this divided by 100. How much is this?
16.87.
How much?
No, wait, that was wrong.
Yes.
48.03.
48.03. Okay. So in your calculator, forget about this symbol, okay? Forget about this symbol and just put the number 92.5 times 51.92 divided by 100. 48.03 rounded. What units are these? Grams of iron 3 chloride. In other words, in numbers, theoretically, you were expecting to get almost 52 grams. But in real life, you only obtained 48 grams, which is very good. That's why the percent yield in this reaction was 92.5%. It's a really good percent yield. I'm gonna send you a video. It's going to be optional to watch it, but it's going to help you a lot to understand more or less how a chemical reaction is, okay, how a chemical reaction actually works, okay? And how do you see all this stoichiometry apply in a real lab with real chemical reactions? The thing is, why do I don't project those videos? So imagine, I started exactly at the time to explain this exercise. I haven't stopped. So it is an exercise that requires a lot of process, okay? So I cannot be like showing you videos or parts of videos here. I wish I could, at least in this topic, I wish I could in this moment, but I know that if I do it, I won't be able to teach all the problem. So I'm gonna send it to you in Classroom. It's going to be optional to watch it. Maybe you like it or not. That's one of my favorite channels too. Okay, so you're gonna see that he's gonna say things like the yield if this reaction was chalala chalala. You're gonna hear him saying stuff like that. You're gonna see how different is a chemical reaction in a lab, even if you are not there, but you'll be able to see quite well. So maybe you like it. Guys, this video was recorded. Watch it again to review this topic. It is important that you guys study a lot. Okay? This is a topic that requires a lot of practice.